Behind every smart device, there is a structured system working silently. Smart homes, smart cities, and smart healthcare systems all rely on one thing: a well-designed IoT architecture. Today, we are going under the hood of IoT. Welcome to Lecture 3. In this lecture, you will learn what IoT architecture is, the layers of IoT systems, how data flows through an IoT system, real-world examples of IoT architecture. How does it work? An IoT ecosystem consists of web-enabled smart devices that use embedded systems, such as processors, sensors, and communication hardware, to collect, send, and act on data they acquire from their environments. These devices share their sensor data by connecting to an IoT gateway or another edge device where data is either sent to the cloud to be analyzed or analyzed locally. To manage this flow of data, IoT relies on a structured architecture. What is IoT architecture? IoT architecture refers to the structured framework that defines how IoT systems operate. It describes how devices are connected, how data is transmitted, how data is processed, and how actions are performed. In simple terms, IoT architecture is the blueprint of how an IoT system works. IoT systems are typically organized into multiple layers. However, the common model is a 4-layer IoT architecture. It comprises a sensing layer. This is the lowest layer of the IoT system. The main purpose of the sensing layer is to identify any phenomena in the device's peripheral and obtain data from the real world. This layer consists of several sensors. Using multiple sensors for applications is one of the primary features of IoT devices. Sensors in IoT devices are usually integrated through sensor hubs. A sensor hub is a common connection point for multiple sensors that accumulate and forward sensor data to the processing unit of a device. Actuators can also intervene to change the physical conditions that generate the data. An actuator might, for example, shut off a power supply, adjust an airflow valve, or move a robotic gripper in an assembly process. In short, the function of the sensing layer is to collect data from the environment and might have two components: sensors and actuators. Sensors in IoT devices can be classified into 3 broad categories: motion sensors, environmental sensors, and position sensors. Motion sensors measure the change in motion as well as the orientation of the devices. There are 2 types of motions one can observe in a device: linear and angular motions. The linear motion refers to the linear displacement of an IoT device, while the angular motion refers to the rotational displacement of the device. Environmental sensors, sensors such as light sensors, pressure sensors, etc., are embedded in IoT devices to sense the change in environmental parameters in the device's peripheral. The primary purpose of using environmental sensors in IoT devices is to help the devices to take autonomous decisions according to the changes of a device's peripheral. For instance, environment sensors are used in many applications to improve user experience: home automation systems, smart locks, smart lights, etc. C. Position sensors. Position sensors of IoT devices deal with the physical position and location of the device. The most common position sensors used in IoT devices are magnetic sensors and global positioning system (GPS) sensors. Magnetic sensors are usually used as digital compass and help to fix the orientation of the device display. On the other hand, GPS is used for navigation purposes in IoT devices. Real-world example: a smart farming system uses soil sensors to measure moisture levels. 2. Network layer. The network layer acts as a communication channel to transfer data collected in the sensing layer to other connected devices. In IoT devices, the network layer is implemented by using diverse communication technologies: Wi-Fi, Bluetooth, Zigbee, Z-Wave, LoRa, cellular network, etc., to allow data flow between other devices within the same network. In short, its function is data transmission and communication between devices using technologies like Wi-Fi, Bluetooth, and cellular networks. Real-world example: sensor data from a wearable device is sent to a mobile app through the internet. 3. Data processing layer. This is the brain of the system. It consists of the main data processing unit of IoT devices. It takes data collected in the sensing layer and analyzes the data to make decisions based on the result. In some IoT devices, smartwatch, smart home hub, etc., the data processing layer also saves the result of the previous analysis to improve the user experience. This layer may share the result of data processing with other connected devices via the network layer. Example: a cloud system analyzes patient data to detect health risks. 4. Application layer. This is the top layer where users interact with the system. The application layer implements and presents the results of the data processing layer to accomplish disparate applications of IoT devices. This layer is a user-centric layer that executes various tasks for the users. There exist diverse IoT applications, which include smart transportation, smart home, personal care, healthcare, etc. Example: a mobile app shows real-time heart rate data from a wearable device. How IoT data flows through layers. IoT systems follow a step-by-step flow. Sensing layer collects data, network layer sends data, processing layer analyzes data, application layer displays results. Simple example: in smart home system, sensor detects temperature, data is sent via Wi-Fi, cloud system analyzes data, and app adjusts air conditioning. Alternative IoT architecture, 3-layer model. Some systems use a simplified structure. Sensing layer. 2. Network layer. 3. Application layer. In this model, processing is included within the network or application layer. The sensing layer. This is the physical layer. It consists of sensors and actuators that sense the environment, like temperature sensors, or act upon it, like a motor that opens a valve. The network layer. This acts as the bridge. It connects the things to other network devices and servers. Its features are also used for transmitting and processing sensor data. The application layer. This is the top layer that defines all applications where IoT is deployed. It is responsible for delivering application-specific services to the user, whether that's a smart home dashboard or a health monitoring app. IoT architecture ensures that devices communicate effectively, data is processed efficiently, and users receive meaningful insights. Without proper architecture, IoT systems cannot function effectively. Real-world perspective. IoT architecture is used in healthcare, sensors collect patient data, cloud analyzes health conditions, and apps provide insights to doctors. In smart cities, sensors monitor traffic, systems optimize signal timing, and dashboards manage city operations. In industry, machines collect performance data, systems predict failures, and engineers take preventive actions. Why this matters to you? Understanding IoT architecture helps you design efficient systems, understand how devices communicate, solve real-world problems, and work with modern technologies. Conclusion. In this lecture, we have learned what IoT architecture is, the layers of IoT systems, how data flows through IoT, and real-world applications. IoT architecture is the foundation that makes smart systems possible. In the next episode, we will explore IoT communication technologies, protocols used in IoT, and how devices exchange data. Thank you for watching. Like, share, and subscribe.